Well, hello students. This is lesson 5 of unit 5. We're going to be learning about recursive rules for arithmetic and geometric sequences today. And we're also going to be iterating functions. So that's kind of stuff that we're going to work at in this next couple of videos. So looking at the beginning of lesson 5.5, just follow along as I read. So far in this chapter, we've worked with explicit rules for the nth term of a sequence, such as the nth term is equal to 3n minus 2. Or the nth term is equal to 3 times 2 to the nth power. An explicit rule gives the nth term as a function of the term's position number n in the sequence. Meaning, if I want the 8th term, I plug in 8, and my rule, my formula, spits out the value of the 8th term. If I want the 12th term, I plug in 12. If I want the 30th term, I plug in 30. And it will explicitly give me the value of that particular term in the sequence. Okay? Now in this lesson, we're going to learn another way to define a sequence. We're going to use recursive rules. So a recursive rule gives the beginning term or terms of a sequence and then a recursive equation that tells how a sub n, the nth term, is related to one or more preceding terms. So again, some notation to understand. A sub n means the nth term in a sequence. Okay. Now that said, you're going to see some symbols like this as well. If you see a sub n minus 1, okay, so if a sub n is the nth term, a sub n minus 1 means the term that came right before it, or the preceding term, okay? All right, preceding here, boy, it's going to take forever. So the preceding term, meaning the term that came right before the one that is the nth term, okay? And then if you might even see a sub n minus 2, well, same thing. If a sub n minus 1 meant, hey, back up one term, well, then a sub n minus 2 is going to mean back up 2 terms, or 2 terms ago is kind of the way that I like to think about it, okay? So 2 terms ago, I'll put right here. A little sloppy, but you get the idea. Okay. If we're asked to write, several terms of a sequence using recursive rules, it's going to look something like this. We're going to be given the first term or the first 2 terms or something like that. So we're told that, hey, the first term in this sequence is negative 2. I'm going to go ahead and write that as the first term in my sequence. Okay. Now, to find the next term, here's how the rules are going to work. You'll see a sub n, meaning the nth term, is equal to a sub n minus 1, meaning the term right before it plus 3 in this case. Okay. So if I want to find the next term in my sequence, I take the term that came right before it, negative 2, and I plug it in, I add 3 to that, okay? So what's negative 2 plus 3? That's going to be 1. And then to find the next term, I take the previous term, in this case 1, and add 3 to it. So 1 plus 3 is 4, and 4 plus 3 is 7, and 7 plus 3 is 10, and 10 plus 3 is 13. So there's 6 total terms. And to find each term, what I did is I took the term right before it and added 3. Took the term right before it and added 3. That's an example of using a recursive rule to write the first 6 terms of a sequence. Now this one happened to be the first 6 terms of an arithmetic sequence written recursively. I could do the same thing if I had the first 6 terms of a geometric sequence. So geometric, we're going to be doing repeated multiplication. So if I'm multiplying for this sequence, 32 is my first term. To find the next term, I take 1/2 times whatever came before it. So the next term in this sequence is going to be half of 32, which is 16. And then half of 16, which is 8. And then half of 8, which is 4. And 4 times 1/2 is 2. And 2 times 1/2 is 1. And there's 1, 2, 3, 4, 5, 6 terms. Okay? So that's writing terms of a sequence given a recursive rule. Now, the way that recursive equations for arithmetic and geometric sequences are going to work is they're going to follow a pattern kind of like this. An arithmetic sequence is always going to take, find the nth term, take the term right before it, and add d, the common difference. Okay? So similar, again, d, common difference, the same thing that we had when we wrote arithmetic sequence rules or formulas explicitly. Okay? Geometric sequence, you're going to take, to find the next term, you take the term right before it times the common ratio r. Okay? So here's my common ratio, 1/2 times whatever came before. Here's my common difference of 3, add it to whatever came before. So that's recursive equations for arithmetic and geometric sequences. Okay. Now, let's do a couple of examples here. So write a recursive rule for the sequence. So if you have to actually write these, your first step is to figure out which kind of sequence is it. Is it arithmetic? Is it geometric? Or might it be neither? Okay. Hint for these where it says special sequence, these are going to be something different. We'll wait with that. Okay. Let's try this one. Write a recursive rule for the sequence. 100 to 40, 16, 32 fifths, 64 25ths. Am I adding something consistently? No, because I'd be adding negative 60 and then negative 24. It's not the same. Am I perhaps multiplying by something consistently? Well, if we were to find a common ratio, perhaps, let's see, if I take 40 divided by 100, that turns into, simplifying that down, it's going to be 2 fifths. Now, if I did this, 16 divided by 40, do I get the same thing? 16 divided by 40, it's going to be 8 goes into this twice and this 5 times, so hey, 2 fifths again. So 2 fifths must be my common ratio. Now, if you want to check it, take 16 times 2 fifths, you'll get 32 fifths, and this times 2 fifths, you'll get this, okay? So that's R, the common ratio. So it's geometric. So if I'm going to write this recursive rule to find the nth term in recursive style, I'm going to take the previous term, a sub n minus 1, okay? I like to put it in parentheses just so I know that's a separate thing, times the common ratio, which in this case is 2 fifths. So I take the previous term times 2 fifths. Now, we're not quite done because we've got, this is the recursive rule, but I don't know where to start. That's the problem with working in recursive rules, is you always have to identify what your first term is so you know where to go from there. Otherwise, if I want to find the next term, I don't know what to plug in here, okay? So if this is my recursive rule, part of my recursive rule would then be defining, okay, we're going to use that rule with the first term of 100. So make sure that when you use recursive rules, you're also including what is the first term, okay? You should always have that a sub 1 there. So this is what that would look like when I'm all done. 2 parts to it, the rule and what the first term was. This next example, we've got, let's see, 8 to 28 to 40. It looks like we're adding 20 over and over again. Again, so check it, 28 minus 8 is 20, 48 minus 20 is 20. So this is a common difference, D of 20. Now I could write the arithmetic formula explicitly, but again, we're working on recursive rules, so let's do it that way. To write this recursively, to get the next term, I take the term that came right before it, a sub n minus 1, and I add the common difference, which in this case is 20. It's as simple as that, and there's my rule, okay? Only other thing, remember, I have to identify, hey, what's the first term? If this is the rule I'm going to follow, where do I start? Well, I start with 8, that's my first term. And this would be my recursive rule written out in its entirety. So that will do for now.